timing. All right, cool. So this is a chemistry demonstration I'm going to show you guys because, of course, I'm a chemistry student, and I like it, and it's going to be fun, trust me. What I have here is liquid nitrogen. How many of you guys have seen liquid nitrogen before? You? Okay. Liquid nitrogen, negative 200 degrees Celsius. Is that cold?
Yes.
Very cold, right? Okay, so we're going to be playing with this stuff, or I am. You guys are going to observe, and I'm going to have you guys participate in the end. So again, what are the three phase changes?
Solid, liquid, gas.
Solid, liquid, gas, right? This, what form is this in? I said liquid nitrogen, so
Gas.
liquid form. Okay. Liquid nitrogen, dangerous. Remember, liquid nitrogen, dangerous. How cold is it? Negative 200 degrees Celsius. So when you play with this stuff, I always do, because I can. You want to use safety goggles and gloves. And I don't want my clothes on the street. Okay, just got that.
Wow, that's cold.
That's not water, my friend. This is liquid nitrogen. Liquid nitrogen, watch your feet, please. Take a look. Where is it going? What's going on? What do you guys see? That is awesome. What happened to it? What did you see? Turned it solid. What else?
That's crazy.
Liquid nitrogen evaporates within a matter of 0.2 seconds. So right now, what you guys actually saw was just liquid nitrogen picking up all the dirt. But it evaporates in the atmosphere within a matter of 0.2 seconds. So what just happened? It went from liquid to gas. Cool. All right, so let me show you some of the cool things that liquid nitrogen can do. Here I have, actually no, I don't want to do this one just yet. Here we have a pretty flower. Okay? Flowers consist of what? What do you guys learn in biology? What's the first thing you learn in biology?
Cells.
Cells. I heard cells.
Is it me?
So what's the first thing? What do flowers have?
Life.
Life. They're living, right?
Yeah.
So just like us, what do they have? Water. Cells, right? So I heard someone say cells earlier. And so, imagine, I bet you guys are wondering what happens if I put my finger in there, right?
Yeah.
Well, let's check it out.
Freeze.
I'm not going to do that. I'm not serious. So imagine this as your finger, okay? Remember, flowers have cells, correct? What about your finger? Cells. So what do you think would happen if I were to freeze this flower?
It'll freeze.
It'll burn? No. So again, this is your finger. Put your finger in there. Oh! What just happened?
It shattered.
It froze, right? Now, why did it freeze exactly? In those cells, what do you have? Water, right? Yeah. So of course, water freezes at a certain temperature. You guys want to see that again?
Yes.
What I'll do is, let me put this in here, and then we'll leave this out, and then just take a look at it as time flies. Leave that there for now. Okay, so here I have a balloon. I blew this up earlier with my own breath. I promise I did. Okay.
Is it going to pop?
No.
So you have a balloon. What's in here?
Helium.
Oh, excuse me, air, right? Is it moving around?
Yeah.
Is it staying still? Are the molecules in the balloon staying still? Moving around, right? So, and also there's air in here, correct? What do you think would happen if I put the balloon in the liquid nitrogen?
Pop.
Would freeze?
Pop.
Pop? Shatter? It's going to shrink. Okay. If you guys don't like loud noises, I recommend you cover your ears, please.
You want to give her their answer?
I'm just messing around.
No, it's shrinking.
It's gonna turn small. It's gonna be
Okay, so what happened to the air in the balloon?
It all
It shrunk. It condensed in, right? So what would happen if I were to just
It's
take
going
it
to start
out?
getting bigger again after a while.
Popcorn.
So cool.
I want to play with that.
It's gonna go back to mom.
Well, unfortunately, now there's a hole in it, so that's not going to work. Let's try this again.
I want to play with it.
Yeah, another blue.
Yeah, I came prepared. Alright. Try this again. Alright, let's try this again.
Turning inside.
This one actually might work. Also, for you guys in the front, if you look underneath, I'm going to lift this up. Careful not to come too close, though. What do you notice? What do you see underneath rolling around? Smoke? That's smoke. Not just the smoke, but look around it. Do you see little liquids moving around?
Yeah.
That's air. Air just turned into liquid form, so that's what you see in the balloon. So imagine air, that's pretty much why the balloon condensed in. The air inside the balloon, because the liquid nitrogen is so cold, it condensed the air, turning it into liquid form. And then when you take it out, because obviously it's hotter out here, right? The air pretty much evaporates back into gas form, and so that's why the balloon expands. Cool? Yes, no, so you guys get it? So that's the balloon. Now, I have here a racquetball. You guys saw me carrying it around, messing with it. It's a real ball. I'm not lying. What's the ball made out of? What's a racquetball? Rubber, right? So, I'm going to obviously let this simmer in here for a while. What do you think would happen to, like you guys said it was made out of rubber, right?
Yeah.
What do you think would happen if I leave this in here for, we'll say, a couple minutes, and then think it'll break?
It'll freeze and then
Freeze, and then if you like,
Freeze and shatter?
yeah.
Okay.
it'll bounce back.
More in here. I don't think so. I'm sorry? He doesn't need more. Leave that in there for a while. In the meantime, while that's going, what do you guys notice also with the liquid nitrogen? It's bubbling, right?
Yeah.
Why do you think that is? It's boiling. What do you think is going on also as we speak?
It's trying to convert to gas.
It's being converted to gas, right? Is liquid nitrogen dangerous?
Yeah.
Yeah.
How dangerous?
Very dangerous.
Break your finger, right?
Yeah.
More.
Really?
It'll be so cool.
And it poke nice.
Okay.
Okay.
Guys have any questions while this is sitting in here?
Looks like a rock.
It looks
Is that the
fine.
only thing, like, is that the only
But it's gonna shatter.
Pretty much, yeah. That's that cold, yeah. Also, what else could you guys use liquid nitrogen for in a research lab? To freeze stuff. That's all, pretty much.
Really?
Yeah. Okay. So hopefully this will work. Because I didn't let this long enough. So you guys think it's gonna shatter?
Yeah.
Does anyone think otherwise?
It's not gonna bounce.
It's not gonna bounce. All right.
Oh, crap.
Wait, do it again.
So no, you're right.
I believe.
I know, I kind of did that pretty quick, sorry. So what just happened? It broke, right? So why do you think it shattered? What happened to the rubber material?
It froze.
It was already solid to begin with, right? So, what happened was, again, how cold is liquid nitrogen? Negative 200 degrees Celsius. What happens is the rubber turns, because obviously it's so cold, the rubber turns into a glass-like material, which causes it to shatter. And also, let me also throw this in here. There's also molecules inside the ball, right? If those molecules are submerged into something that cold, what do you think happens to them? Remember, they're moving around.
They slow down.
They slow down, they stop. So, also that's why the ball loses its bounce, correct? Ball loses its bounce, and also it turns into a glass-like substance because the outer layer is pretty much frozen. Now, if we wait, let this thaw out, or cool, whatever, eventually this will turn back into rubber. It won't go back into a rubber ball, because we've broken it, obviously, but it'll turn back into being rubber.
So that means the road's already back to normal?
No, actually, it's welting.
What is that? So it's going back?
It's pretty much going to die pretty soon.
Can you put it again?
We just didn't shatter it, that's it, yeah.
Die.
Like, if you compare it to this rose, which is
Alive.
alive, you see how it's all like nice and, fluffy,
Yeah.
sensitive. Look
That
at
was
this.
how it died.
Why does it still
You
bubble?
killed it.
Why is it still bubbling? Because it's evaporating. So as it's evaporating out, that's why it bubbles out. See that? Okay, this one I'm gonna do last. Because I want you guys to try this. Okay, so
We're gonna eat crackers?
okay, so is liquid nitrogen dangerous?
Yes.
How dangerous?
Really
Very dangerous. Can I put my finger in there?
No.
So if I were to say, hey you guys, I'm hungry. I did not eat all morning. I didn't even eat last night. I'm gonna dip this in there and eat it.
Probably die.
Probably bad.
Probably die.
I probably die.
No, probably
No.
poison.
What do you think will happen?
Nothing.
It'll melt.
No.
Yeah.
It'll freeze you.
Okay, if I die, you guys, someone could have my phone. Someone needs to take it.
Awesome.
All right.
I'll take it.
Oh.
It's just really cold.
No, seriously, I didn't eat all morning.
You wanna do the ring?
You know what? Why didn't anything happen to me?
Because it's just really cold.
It's cold, but
It's like
heated
eating
up
ice.
before it would
You're on the right track. Keep going.
it heated up before it would
Okay.
freeze you? Or
You know before. Okay. No, no, that's
Your body
You're actually. I'm sorry.
Your body temperature?
Body temperature, right? Okay. You guys are on the right track. Actually, that was really good.
magic.
Okay. So.
Can I have one?
So, hold on. Let me talk. Okay, so in these crackers, what do you guys notice?
There's
There's
holes.
holes. And so these holes, think of them as little air pockets, okay? What's going to happen to those air pockets when they're in the liquid nitrogen? They're going to close, right? It's frozen over. Is your mouth warm or hot? Warm or cold?
Warm.
Warm. So what's going to happen to those air pockets when you put it in your mouth?
They open back up.
They open up, and then it forms the steam. The steam is your breath, you know, from the reaction between the liquid nitrogen and your and the heat from your mouth. So kind of like when you guys, you know, when it's foggy outside, same effect, but this is better because it's more, you get a better effect out of it, obviously. Let's see. You guys want to try it out?
Yeah.
Yes.
Okay, ground rules, more rules. Sorry.
I have a question.
Yes.
Okay, you know how that's like frozen?
Mhm.
If we touch it, is it like better now? Like
You can touch it. Yeah. This one?
No, that one.
This one?
Yeah.
Yeah, you can touch it. Like when you guys come up, go ahead.
Uh-huh.
Go ahead, you know, take a look at it. You guys could just, okay, well, before, let me rephrase that. I'll put this here. If you guys want to look at the racquetball, I'll put it here. But ground rules, don't touch the table. I'm sorry, but I'm just going to let you know now. Don't touch the table. I don't want anyone getting hurt from this stuff. This stuff is dangerous, okay? I'm not, that part, I'm not joking around. I'm going to have you form 2 lines. You guys are going to dip the cracker in yourself. I'll supervise you. Don't worry about the flours. It won't mess up the taste. And don't worry about germs because it's so cold that it'll kill all the germs. You're going to form 2 lines, dip it in, blow out. Don't go like, because what's going to happen is it's going to hurt your throat, okay? If you have sensitive teeth, I recommend don't do it because it might, braces you're fine. If you have sensitive teeth, think of it this way, if you can't eat ice cream, don't do this. Alright? Alright, so give me 2 lines. 2 lines. This way, don't touch the table, and you guys can have your breakfast later. Want some?